Hello and welcome to our presentation on LibComp, an IntelliJ IDE plugin for Java library metric comparison. My name is Rehab El-Hajj, and I am an undergraduate computing science student at the University of Alberta, and I'm going to present our tool, LibComp, which I worked on with Dr. Nadi, who is also at the University of Alberta. Let's start by motivating our work. It is no surprise that selecting libraries can be a time-consuming and tedious process for software developers. There are many factors to consider, such as whether that library has a lot of documentation, if it is popular, how often it's updated, and more. We have thus created metrics to measure these factors. Because of this problem, it would be ideal to have some form of centralized data that contains all the necessary information that we might need when selecting a library, all in one place. Having this information together could aid developers in decision-making when they select a library, and this can really empower the developer by reporting all the data that they need to make an informed decision and leaving the actual decision to them. But what exactly can we consider when we say metrics? Well, on this slide, I have two of my personal favorite examples of metrics we consider for library comparison. The first is popularity. In our case, we operationalized popularity in querying GitHub to get the top 1,000 repositories in descending order of stars. Then, once we had these top 1,000 repositories, we asked ourselves this question: how many of these repositories use our library in question? Then, we actually searched through the 1,000 repositories to see how many of them use the library. As you can imagine, we generalized this number to assume that the more repositories that use the library as an import statement, the more popular that library is. For an example of another metric, let's look at last post on Stack Overflow. For a metric such as this, we mined Stack Overflow for the library in question to find when that library was most recently discussed. This can give us an indication of various things such as how popular it is and how often it's discussed. The more questions there are in Stack Overflow, the more answers you potentially have if you choose to use this library. Last post on Stack Overflow metric also gives us an indication of the level of documentation that may or may not be available for a specific library. So, by combining what we have just discussed about our motivation for library metric comparison and the types of metrics we might see, we come to this slide where we see some of the previous work from our lab that actually went ahead and combined these metrics into one centralized location, being a website. This website has great benefit for developers as it displays information about many library metrics in one location. But a key drawback is that this location is an external environment from your IDE. So say you're working on some code and decide you need a database library. You will then have to leave your IDE environment, go to this website, look into these libraries, and make a decision. But what if we could do all of this within your IDE? What if by the click of a few buttons in the same environment, we could easily compare and contrast different libraries that are similar to one another and choose or replace the best one? Well, lucky for you, this is exactly what LibComp can do. Let's take a look at this slide here to see a little clip of how we use LibComp. Here in our IDE, we have some import statements where we see that they are highlighted in pink. What this means is that our plugin, LibComp, recognized those libraries from our central database, and so it highlighted them in pink to let you know that alternatives exist if you choose to explore them. By clicking on the line and choosing library comparison, we see a dialog pop up. Then, from this dialog, you can see alternative libraries that you can select one of them, click replace, and now you've just replaced a library within your IDE, just like that. Now we see a close-up of that replacement dialog we saw on the previous slide. This is the dialog you would see if you were to click on an import statement looking for possible library replacements or alternatives. Our rows refer to the different metrics, such as those familiar metrics we've already discussed, like popularity and last Stack Overflow post. However, we also have other metrics, such as release frequency, issue closing time, issue response time, and so on. our columns contain all the alternative libraries and our current library, which we clicked on, which all belong to the same domain. In this example, we're looking at libraries within the mocking domain. We can clearly see here that Mockito is labeled as the current library, or the library that you have just clicked on, and JMock in blue is the library that you have selected to replace Mockito with. From this dialog, I can also click on the graph icon on the far left to get a graphical representation of any of the metrics of my choosing, or I can click either the red downwards arrow or the green upwards arrow to sort based on a specific metric by ascending or descending order. So if you care most about popularity, no need to look through all of the existing libraries. Just sort it in descending order, and you have your most popular library in the mocking domain, which you can choose. As we can see here in this video, this is the little clips showing the sorting feature in action, where the columns themselves are rearranged in either ascending or descending order, depending on which arrow you click and what row the arrow is in, which refers to different metrics. We also want to note that while in our example, we only looked at import statements, LibComp also works on build files for both Maven and Gradle projects. So it will highlight in pink the dependencies if we have information on them in our database. And then you can click on it and click library comparison and reach that same dialog, which we just looked at in the previous slide. From that dialog, as we discussed, you can compare different libraries via a wide array of metrics and choose the best library based on your analysis. Another feature of LibComp is the ability to enable or disable comparisons for a domain. Say you use LibComp to decide on the database library H2, seen on line 6 of this image, and are content with that decision. Then you no longer want to see in pink highlighting all the database libraries since you've already chosen one. If that is the case, all you have to do is right-click on that line and select Disable Comparisons for this domain. This will stop database libraries from being highlighted and is reversible at any time if you change your mind. Something else we have implemented from our end is a data interaction and feedback system where if a user fills out the relevant forms seen on the right side and gives explicit permission for their information to be stored, then when they use LibComp, we will track their usage of it. This gives us information on what libraries users tend to replace and what libraries they replace them with, and what their import statements are at the time, and gives no personal or security risk information. This could also help us gather information on library migration patterns going into the future as we collect more data. Overall, we have now discussed the general framework of LibComp and its functionality as a library comparison tool within the IntelliJ IDE and how we can use it. We also delved a bit into the specific features of LibComp and looked closer at the library comparison dialog and what features are embedded within it. Note that currently, our database houses information on 50 Java libraries belonging to 13 different domains. This data is easily extendable, so if you want to contribute, please refer to our GitHub link on this slide. If you have any comments or questions, please feel free to go to our GitHub and contact us. Thank you.